One of the biggest limitations in VR is the play area. As the player movement is restricted to a small zone, how can we, as a VR developer, let our players explore the world we built for them? Welcome back to the third part of this tutorial series that will teach you the basics of VR development in Unity. And in today's video, I will answer the question by showing you how to make a teleportation system using the Unity XR Interaction Toolkit. I'm Valem and this channel is all about VR development, so if you don't want to miss the next video, make sure to subscribe and ring the notification bell. But without further ado, let's jump right in the tutorial. Okay, so we are back where we were at the end of last episode with Hand Presents. Now, to enable teleportation, we will select our VR rig that we created in the first episode. Then, I will add two new components, the locomotion system and the teleportation provider. As you can see, the locomotion system needs a reference to the rig and the teleportation provider a reference to the locomotion system. We could reference them right there, but if we press on play, you can see that they get automatically set, so I will just leave it like this. Now we will create the ray that will let us point the destination we want to be teleported at. To do this, we can right-click in our hierarchy and go to XR Ray Interactor. This will automatically generate a game object with the component that we need for the teleportation. By the way, you can see here other shortcuts to create XR elements, like the XR rig we created by hand in the first episode. This shortcut can be really useful if you want to quickly set up a scene, for example. Now I will drag the Ray Interactor as a child of the camera offset under my XR rig. Make sure that its position and rotation is at 0, 0, 0, and I will rename it to Right Teleport Ray. Finally, we can go in the XR controller and change the XR node to right hand. We can see that the Ray Interactor has a lot of components and parameters that we can use, and I will take the time to browse them with you. But for now, let's click on play to test what we already have. Okay, so as you can see, we now have a red ray that spawned from our right hand, but it doesn't interact with anything, so let's make some interactable for ray. So the interactor ray can interact with several types of objects that are far away, it can grab objects that are far from us, or interact with the user interface, for example, which is pretty neat. And that will be the subject of another video, but in our case, we will use it to select the position we want to teleport to. So there are two types of teleport interactable that we can use, the teleport area and the teleport anchor. Let me quickly create one of each to show you the difference. To make the teleport interactable, we will use a shortcut by going on the hierarchy, then right-click, go to XR and click on teleportation area. We now have a white plane in our scene, which is causing some Z-fight with our black plane. The Z-fight appears when two meshes are superposing each other, so to fix it, we can scale down our teleport area, place it behind the player and slightly increase the Y position just like that. And there you go, now we will be able to teleport everywhere on this plane. But this just doesn't apply to a plane, we can create a teleport area on anything that has a collider. For example, here, if I create a cube and place it next to the plane, we can simply add the teleport area script to it, and this is now a valid teleport area. Be careful here that for the teleport area to work, it needs a collider, as you can see from this variable. If you have one next to the component, like in my case, it will automatically be used by the area, but if you don't have one on the same game object, but in a child, for example, just drag it here in this parameter, okay? Okay, so this was for the teleportation area. Now let's create the teleportation anchor. As before, I will right-click on the hierarchy, go to XR, select teleportation anchor. So as you can see, we have another plane on our scene now. We can scale it down, make it a bit smaller than the other plane and place it next to it. Don't forget to increase its height to remove the Z fighting. Okay, so already we can see some differences between the area and the anchor. First, well, the name of the component is different, okay, but in the case of the anchor, we have an additional parameter called teleport anchor transform, which references a child of the plane that we can see here. So compared to the teleport area, which lets you move around the area freely, the teleport ensure will teleport the player exactly at the position of the ensure. And if you want to set the rotation of the player with the ensure too, we can go to match orientation and select camera instead of known. Now let's see how this works by pressing on play. And there you go, already you can see that if I point the laser to my area, the laser turns white. And now if I press on the grip button, ta-da! I'm teleported on the position my laser was pointing at. And it works too for anywhere on the cube platform. Now for the teleport ensure, you can see what I talked about earlier. If we select it, the position and the rotation of the player will be set to the ensure. Really nice. So there are some little things that I want to tweak. First, I don't want to use the grip button to teleport, but use instead the trigger button, which I prefer. To do this, we can go back to the XR controller component of the teleport ray and change the select usage to trigger. Now here you have also the axis to press usage, which is the threshold value to accept the teleportation. In my case, I will set it to 0.2, which means that when pressing above this value, we will teleport. So at the moment, the ray can interact and be blocked by everything, which is sometimes what we want. So for example, if I create a wall here by making a cube, call it wall, scale it and place it in the middle of the area. And if we press on play, you can see that the ray doesn't pass through the wall and we cannot teleport above it. So if you want to exclude something, I will show you how to do this, and this will be the case for this bowling ball from the first episode. Because as you can see with the ray interactor, we can interact with it to grab it. And this is not what we want to do with the teleporting rays, so to exclude the bowling ball, I will create a new layer by going here on the top right corner, click on Add Layer. There you can see all the layers that are currently used by our game. I will create a new layer called Grab. So now I can go back to the bowling ball and set its layer to the new grab layer we just created. And now what's left for us to do is go to our teleport ray, and below here we have a recast mask which is set on everything right now. But if we want to exclude the grab layer, we simply need to make sure it's not selected here. Perfect. And now if I press on play, now you can see that I can teleport anywhere. The wall still block our teleportation, but I cannot interact with the bowling ball. We can make some more adjustment. For example, if we take a look at the select action trigger variable, let's select state instead of state change. Basically, what this does is that with state, I can go in an invalid zone, press the button, and then go in a valid zone and I will be teleported, which would not be the case with the state change. And basically, that's it. We've succeeded to make in a few minutes a teleportation system for our game and learn how to tweak the parameters. Pretty cool, right? But I know that if you have watched this video till this moment, you want the good stuff, right? You want more. So I will show you how to update the look of the teleportation from this to this. Are you ready? By the way, if you enjoyed this tutorial so far, please leave a like below to help the channel grow. Okay, so the first thing I'm going to do is go in the XR Ray Interactor component. As you can see, we have some settings for the line type here. For teleportation, I think it would be better to change it from straight line to projectile. Now, if I click on play to test the difference, we now have a sort of fishing rod to select our destination, which is way easier for the player if we don't want to break his hand. We can even update the settings while playing to make it better. In my case, I will decrease the velocity to 8 and leave the other settings like these. Be careful here, as we've updated the component while playing. If we leave play mode, the component will be reset. So before leaving play mode, copy the component and paste it again afterwards. There we will have the same properties we made in the play mode. Finally, I will uncheck the enable interaction with UI here, as we don't want to interact with those. And below you can see that we have some additional settings to improve our system, like playing an audio when we enter or exit an area, or vibrate the controller. In my case, I don't have audio in my project to use, but I will use haptic feedback when hovering over a teleport area. So I will check the play haptic on hover enter, set the intensity to something small like 0.1 and duration to 0.12. I can maybe play a vibration also when we press on the teleport button, and this time make it a bit higher to 0.3 on the intensity. Perfect. By the way, you can see that you can trigger some custom event using the interactor event below, for example, and that can be really handy if you want to show the controller or a text, for example, or anything you want using the interactor event. But in our case, I will just leave it like this. Okay, we are getting somewhere with our teleportation. Now there are two other components on our right teleportation array game object, a line renderer and the XR interactor line visual. As the name mentioned, both of them are responsible for the look of our teleportation, so let's make it beautiful then. The first thing that I want to show you is the reticle. As you can see, we have a reticle variable that we can use to see our destination. For example, to create a simple reticle, I can right-click in my hierarchy, go to 3D, cylinder, call it teleport reticle, remove the collider and scale it down to 0.6 and scale it down again on the y-axis. Now to make it look prettier, I can create a new material by going in my project folder, right-click create material, call it reticle base, set its shader to maybe universal render pipeline unlit, surface type transparent, and finally set its color to a deep blue. Now we can drag this material to our reticle, and you can see that if we decrease the alpha value of the color, we can make it transparent, which is pretty good if you want the player to see through. Now what's left to do is to drag it as the reticle variable of the XR interactor visual line. And if we click on play, perfect, now our reticle is showing when we enter a valid teleportation. Awesome. Now let's keep making things beautiful. So as we are using the universal render pipeline, for this project I want to make use of a new tool called shader graph. Shader graph lets you create beautiful shader really quickly without any code, which can make some really nice effects. And this is what I will use for our reticle. By the way, if you have never used it, I think you will do fine with this tutorial, but if you want to learn more, I will put a link in the description below. And if you don't use URP, but instead the 3D pipeline, no need to worry, I will also put a 3D version of the shader in the description, which you can download to follow this tutorial. First, I will right-click on our reticle, create a new 3D cylinder to make it a child of it. I want to scale it to create a sort of beam and remove the collider like we did for the base. Now on this cylinder we will create a material using a shader that we will create with shader graph. The shader will create a gradient between two colors, which will make a nice looking effect, I think. So first let's right click in the project, go to create, shader and select unlit graph for this one. We can name it color ramp. Now as you can see, if we click on open shader editor, we have a new window opening to make our shader. So let's drag it above here to make it on a separate window. And here we go, now we are ready to work on our shader. By the way, if we go on the settings of our main node, you can see that we have some additional properties. In my case, I will set the surface to transparent and render the shader on the two face. Perfect. Now for the effect of this shader, I will create two colors as parameter by clicking on the plus button here on the left side and choosing color. We can call the first one top color and name the second one bottom color. Now to make a gradient based on the height of the model, I will first need the local height by right clicking in our windows, create node and search for the position. Now as we want the local position, I will set the space to object. And to get only the Y value of the position, I can take the position, give it as an input to a split node and take the G value here. To make the gradient based on the height, I can create a new lerp node. The first parameter will be our bottom color and the second one will be the top color. and the looping value will be set using the height we just made. Now here we go, we can drag the output to the color node over there and we have our shader. Nice! Now let's click here on the save asset, go back to our scene. If we right click on the shader, go to create material, you can see that a new material is created with the shader already on it. Then we can apply it to our material, and now I'm able to update the color of the cylinder and create a gradient. Awesome! There is one last thing that we can do, however. As you can see, the shader doesn't use the transparency of the color, so let's click back on our shader, open the shader editor, and to use the alpha value of the color for the transparencies, we simply need to create another split node, take the output of the lerp and only take the alpha channel of the resulting color and drag it in the alpha of our master node. And here we go, if we save our asset once again and we go back to Unity, we have a beautiful beam for the teleportation. In my case, I think that I will go with a black transparent color on the top and a deep blue with a bit of transparency on the bottom. Don't hesitate to play with this value to make it your way. Okay, finally, for a little touch of magic, we can add some particle effect for the reticle. So let's right click on the base reticle, go to Effect, Particle System. Now we can quickly update our particle to have a nice effect. Now we can reduce the size of the particle system, rotate it to face the up axis. I will set the start lifetime of the particle to 1 and the start speed to 2. Now we can go in the color over lifetime and enables it. I will create a new gradient for a particle. At the start, I will set the alpha to the max value with a blue color. And at the end, I will set the alpha to 0 and make the color white. And here we go, this looks really cool already. Finally, we can go in the renderer settings and instead of using this material, I will use the default particle one. Perfect. And here we go, now we have our beautiful teleportation reticle. Finally, now that we are ready with our reticle, I think the best thing is to drag it as a child of our right ray. Then let's click on play to see the beauty of what we made. Here we go, now as you can see the reticle is looking great, we did a good job. By the way, if you want to get rid of the shadow made by the cylinder, just select it and here in the renderer lighting settings, set the cast shadow to off. Now that we have a good looking reticle, I want to modify the line, and in my case I will show you how to create a dotted line like this, which I think looks really cool. First we'll need a texture like this one. It's just a simple rectangle with some alpha on the side. I will leave a download link for this texture below to spare you some time to reproduce it. When you import this texture, make sure to set the texture type here to Sprite 2D and UI, also that the alpha is transparency is checked over here, and finally that the wrap mode is set to repeat. Normally these are all set by default, but we are never too careful. Now let's create the shader for this line. I will start by right-clicking in the project folder create shader, and this time choose 2D renderer sprite unlit graph. We can call it dotted line and open the shader editor like we did earlier. Now this shader will be really simple and it will need only two parameters, a texture 2D for texture and a vector2 variable called speed. Now to use our texture, we simply need to create a simple texture 2D node, drag our texture variable in the texture input. So this node is there to link the UVs of our 3D model with the texture. We can drag it in the color slot of our master node. Now to create a moving dot, we need to offset the UVs. To do this, let's add a tiling and offset node. To offset over the time, we can use the first value of a time node with our speed variable and multiply them together with a multiply node. Finally, we can use the output in the offset input of the tiling and offset node and then connect it to our sample texture. And here we go, now let's save the asset and test it in our scene. As always, we can create a material for the shader by right-clicking on it, create material, and here we go. Now to use this material on the line, let's select our right teleport ray, go in the line renderer and replace the material over there by our new material. Let's click on play to test what we've made. Okay, so as you can see, our shader is on the line, but it's not moving. And this is because we have no speed. So let's go down here to the material settings to change it. Now, in my case, I will set the speed to -2 on the X value to make it look like the line is going forward. And there you go, it's looking really good already. But for now, the texture is working on the whole line renderer. To make it distribute evenly, we can simply change the texture mode on the line renderer to tile. And there you go, it looks really cool now. As always, before leaving play mode, make sure to copy the component of our line renderer to paste it again afterwards. Okay, I think we are almost done with our good-looking teleport system. I hope you're still with me. Now you can play with the other settings of the XR line visual to make it to your taste. In my case, I've used these two color gradients, and here we go, now we have our final result. Awesome! By the way, if you want to enable teleportation with both hands, it's really easy. We simply need to duplicate our right ray teleport, rename it to left ray teleport, and change the node of the XR controller to left, and here we go, now it is perfect. I can teleport with both hands. Now we still have a big issue with our teleportation. As you can see, our teleportation is always enabled, which can be really annoying for your player. Imagine if you was fighting demons with a sword in VR and that the beam was always showing. Now let's quickly fix this. First, I will create a new component on the VR rig called locomotion controller. Now on this script, I will start by adding using Unity engine.xr.interaction.toolkit at the top. I will need the reference to our teleportation ray, so I will create two public XR controller variables called left teleport ray and right teleport ray. Now to activate them, I will need to choose a particular button. So for this, I will create first a public input helpers.button variable called teleport activation button, and then a public float variable called activation threshold. So this activation threshold will need to be below the same threshold that we use on the XR ray. So as the teleport threshold is at 0.2, let's set the ray activation threshold to maybe 0.1. Now, as we saw from the previous episode, we can check the input using device with try get features value. Now for the script, I want to show you a little shortcut that you can use for the input system using the input helpers button. So first, let's create a new function called checkIfActivated. This function will take as an input an XR controller called controller and will return a boolean to say if we need to activate the ray or not. Now to check if we pressed on the button, the shortcut is the following. I can call inputHelpers.isPressed following by our device. So in my case, I can access the device of our ray by the controller using controller.inputDevice, followed by our activation button, then the output, so out bool is activated, then our threshold, and finally return the is activated value. Now that we have a function to check if we have activated the teleportation, I will call it in the update function. So if we have left ray, if left teleport ray, then I will take the left ray game object called setActive and activate it with the value we get from the function we made on the left ray. So check if activated left teleport ray. And here we go, now I can simply copy this and use it in the same way for the right ray. And there you have it, our script is over, let's go back to the Unity inspector. Okay, so finally we can drag the left ray in the left ray variable and do the same for the right one. For the activation button, we need to set it to the same button we used for the teleportation. So in my case, it will be the trigger button. And there we go, everything is now ready. We can click on play to test our game. And here we go, now the rays are only showing when I press on the trigger button just above the threshold value, and when I release it, we get correctly teleported. Awesome! And that is all for today, guys. We have finally finished the setup for our teleportation system. Anyway, thank you for staying with me through this tutorial series. In next episode, we'll have a look at the second main locomotion system, the continuous movement. As always, if you think this video deserves it, you can leave a like below. By the way, if you want to learn more advanced subject like this course on how to make a zombie shooter game with the Unity XR toolkit, please come check out my Patreon, the link is in the description below. And on that matter, a big shout out to all of my supporters from Patreon which made this video possible. And welcome to the new one that joined this week and are on the right side of the screen right now. Anyway, thank you for watching till the end and see you in the next one.